Hello friends, as we know that Mahindra is going to start SO classes. So today I represent networking topic. I will share networking topic with you. So let's start networking. As we know that networking is the perfect, in SO exam, networking is the main topic. We can say minimum 20 to 25 questions will be asked from the networking and minimum 15 to 20 questions will be asked from database. So seeing from that, we will start from networking today. Before coming to networking, let's see what is the main networking. See, networking is what? First of all, I will tell you the difference between network and networking. What is a network and what is networking? Let's say what is a network? Network means when we have a room or we have a class and the computer are connected with each and other. So when we will connect that computer, that is called a network, and when we will share information from one computer to the another computer, that we known as networking. And today we will learn what is networking, not networks. So let me start. This is the first slide we are seeing. Here we have a sender and a receiver. What is a sender and what is a receiver? Sender sends messages to receiver with a transmission media. What is media? Media means through cable or through any Wi-Fi or anything. Now here a sender will send the message to a receiver and receiver will receive the message from sender. And here sender will also use some protocols, as we are seeing here that sender is also using some protocols, and sender will send through protocols to the receivers and receiver will receive the message. Now coming to the next slide, here we are seeing that there are two types of digital transmissions. Number one is analog and number two is digital. As I can say, what is analog? Analog means I am saying a voice. Voice means I am saying, I'm louder and louder, and the person who is sitting there backside or front side, he is listening. When he will, from the first person, when he is listening, he will get a clear voice, and the person who is sitting backside, he is getting some low voice. So this is a analog, we can say, a human voice which changed accordingly. The person who is very near, he will listen more carefully, and who is far, he will listen very less. And here in digital signals means it will may take only discrete set of values within a given range. I mean, the signals will be sent in one only transmitted way, only one single way. Now coming to the next slide, mode of transmissions. Let us take what is mode of transmissions. We have a sender and we have a receiver. Sender sends the message to receiver. When sender sends the message to a receiver, receiver takes the messages. First sender sends the messages to receivers. Now when sender sends the message to receivers, sometimes receivers don't know whether the message has been sent or the message has been recovered by the receiver or not. And here the sender will send the message and receiver don't know whether sender has sent the message or not. So we have different types of transmission mode here. First one is simplex mode, second one is duplex, and third one is type of duplex, that is half duplex and full duplex. Let us say taking first simplex mode. In simplex mode we have two computers. First computer will send the data to second computer, and second computer don't know whether first computer has received the data or not. Then again first computer will send the data to second computer don't know whether they have received the data or not. For example, let's take a pager. As we know that pager, as nowadays we are using mobile, but before that we are using a pager device. That is mostly used in some newspapers and agencies, like they are sending the messages through pagers. I mean, suppose a person want to come on Sunday, so the company will send the message that he had to come on Sunday through message transponder, and the message transponder will send the message to a pager. Here also we are taking example of radio. What is radio? Same here, we are listening music, we are listening some voice. that is a radio, and radio is also example of simplex mode. Then TV is also, we are watching the TV. For example, we are watching cable channels. So that is also example of simplex mode. Now coming to the next slide. This is the mode of second transmitter, that is duplex mode. In duplex mode, we have two types of transaction. Number one is half duplex, number one is full duplex. First is half duplex. What is half duplex? Half duplex means when sender send a message to a receiver, receiver takes the messages, and then receiver send a reply that he has received the messages. Now sender will send the message to a receiver, receiver will listen the message, and receiver respond to sender that he has received the message. For example, walkie-talkie, I can say. Walkie-talkie means I am sending the message to a particular person, and that person is listening the voice, and after that he will get back, he will reply to me that I have received the message. Here what I am saying, this is the half duplex, and this is the full duplex. Here both the conversation will go in both the directions. Sender will send the message to a receiver, receiver will listen the message, and receiver will respond to the sender, like telephone, mobile, as we can see. Now there are some communication medium. What is the media? What is medium, I can say. Medium means sending the data from one place to the another place, or sending the data from one building to the another building. For example, I am using some different types of media here, like guided media and unguided media. What is guided and what is unguided? Guided means, suppose there are two computers here we have, and we are connecting two computers with the help of a cable. So that cable is, we can say, a guided media or wired media. And second one is unguided media. Unguided media means we are sending the message through Wi-Fi or wireless. Now coming to the guided media. This is the example of guided media. First one is twisted pair cable. Twisted pair cable, where we will see this twisted pair cable in telephone network. Here twisted pair cable, it has one outer insulator PVC cable, and it has solid copper conductor over there, and it will the distance of this cable will be up to 1 kilometers. It can cover 1 kilometers more, and it is widely used, as I told you, that it is widely used in telephone networks, and the speed of this cable is up to 1 to 2 Mbps. So this is the example of guided media. First example we are seeing. Next one is coaxial cable. This is the second example, as we have cable connection at our homes, and in that cable connection we are using the cable of coaxial cable. That is the best example I can say. That is the best example of that we are using coaxial cable in our cable network. Here this coaxial cable have the outer jack, and in outer jack it has branded shield. In branded shield it has foil shield, and has central conductor. This is the central conductor, and here this is the dielectric. This is the plastic core we have, and this is the same central conductor. I can give you one more example of this, that in our homes, suppose this cable, this coaxial cable has been broken. We can easily join that cable, because here we are only using the central conductor. That central conductor will be easily, we can combine both the conductor easily. But here also we are seeing the examples that we use this type of cables in TV operation, speed broadcasting, and there are two types of coaxial cable. One is 50 OHM, one is 75 OHM. 50 OHM cable we are using in cable TV network, and 75 OHM we are using in broadband network. Now coming to the second example, this is fiber optic cable. Fiber optic cable, we will use fiber optic cable in long distances. Like I can give you the example of Google. Google is using fiber optic cable. Google's head office is in Hyderabad or in Bangalore, and he will transmit the data from India to US through fiber optic cable. Now, why we are using fiber optic cable? Because it consists of 5 different wires, different cables, and the speed of this cable is very high. I mean, it has 101.7 Tbps over 100 miles. I mean, I can say that the speed is very high in this when we are using this type of cable. And I will also give you an example like Airtel, Vodafone, all these types of different companies, operators also using this type of cable for broadband. Now, coming to the next slide, as we have discussed the guided media, now we have unguided media. Now, as I told you, that guided media we have a cable, and unguided media, that is wireless. It has large geographical area, we can say. I mean, we have a tower here. I will give you the example of radio, or I will give you the example of mobile, as we are using the mobile towers, as we are using the radio waves. And also you can say, as we are using at our homes the that cable, I mean that Tata Sky or Airtel, that is also example of some this unguided media. So we will take some more examples, like microwave is also the example, satellite is also the example. In microwaves, we can say we are using microwaves at our homes to cook the food. And for satellite, we are sending the data from one place to another place. Now, network architecture. What is network architecture? There are 2 types of network architecture. One is peer-to-peer, another one is client-server. What is peer-to-peer? Peer-to-peer means from one, there is 2 systems, they both are connected with each other. One system send the data to second system receive the data and it will send to first system again. Now first system will reply to second system. This is peer-to-peer. I mean, each system is connected with each other. As we are seeing the definition, it is a type of decentralized and distributed network architecture in which individual node in a network, as I told you, both the systems are connected with each other. First system will send the data to second system will send the data to first, and acts as both suppliers and consumers of resources. So this is peer-to-peer. Now we will come to client-server architecture. In client-server architecture, we will say in our office, we have a client-server architecture. We have a server with us, and the server will connect it to different computers. Now this computer will respond to the server, this system will send the information to a server will respond to the client will send to the information to a server will again respond to the client. So this is client server architecture. As we can see the definition, in communication network, a node is connection point. The device used to communicate a data communication network is called workstations. As I told you, this is a collection of workstations also, as we have a server, and server is connected to different systems, different clients. Now, as for giving the example, we have printer, we have telephone, as it is written here that terminals, printers, telephones, these all are the examples of network architectures, client server architecture. Now, coming to the classification of network, how we will classify the network? First is LAN, second one is MAN, third one is WAN, fourth one is PAN, and fifth one is CAN. As we talk about LAN, suppose, what is LAN? Local area network. A small area, suppose a class, or suppose a building. When we connect different computers in a building, or when we connect different computers in a class, then we can say that is local area network. As we are not using any other thing, so it is a very small network, so we can say it is having high speed. I mean, it has a high speed because it is work in small geographical area network. It is also shared network, we can say. We can share this network. I mean, suppose I am going to the office, I can share that network with my mobile or my laptop. Now, second one is, now In this network, LAN network, we are using a Ethernet cable. The example of Ethernet cable, I can say, we can see in our classroom also the system, the computer is connected. I mean, it has a blue cable that is connected with the computer with RJ45, RJ45 connector. So this type of cable is, we can say, the Ethernet cable. Now, second one is Wi-Fi wireless fidelity. As we know that we are at presently, as there is a digital media over here, so we are using a Wi-Fi network nowadays. I mean, as all we know that we are using a hotspots also, like we want to connect one computer to one system to one mobile to another mobile, or we want to connect mobile to a system, or we want to mobile to a different mobile. So sharing of Wi-Fi, we can say that is the example of Wi-Fi fidelity, or we can say Wi-Fi. Now there are some standards of Wi-Fi. First is 802.11e, second one is 802.11b, third one is 802.11g, and fifth one is 802.11n. Next is wide area network, WAN. In LAN we have a small network, but in WAN it contains a regional network, we can say, or a metropolitan area network, or in national boundaries, we can say. For example, I can say WAN, we can use internet. I mean, whenever I am opening any website, that is also example of WAN. I mean, that is example of internet. Now we have communication devices. Before that, I will also tell you that what is PAN and what is CAN. MAN, we know that metropolitan area network, then we are using in a geographical area. I mean, suppose we can say a cable network is an example of MAN network. And for PAN and CAN, PAN is personal area network at our homes whenever we are connected to a computer, that is our PAN network. And CAN network, campus area network, when two different buildings are connected with each other, then it will say, we can say that is CAN, campus area network. Or we can say the example of universities or colleges, which are 2 or 3 buildings, and that all buildings are connected with each other. So they are connected with the help of CAN, campus area network. Now coming to the communication devices, first one is modem. Before coming to modem, I can say what is a communication device. I mean, when we are communicating to a network, or when we are communicating to different networks. Network and different network means in a single building, or networks means it has 2 buildings, more than 2 buildings, or it has n buildings. Now here we take modem. Modem is what? What is the purpose of a modem? Modem, there are 2 types of modems. Modem is what? Modulation and demodulation. Modulation, demodulation means my computer knows digital signals, but the cable which is connected to my computer, that contains analog signal. So we will convert that analog signal with digital signal with the help of modem. Again, after modem we have VSAT. VSAT, very small aperture terminal. I will give you a small example of VSAT. Let us take we are using a ATM machine. In the ATM machine we are using VSAT technology. When I am fetching a card, when I am swiping a card, ATM card in the machine, that machine has connected with a device that is known as a VSAT device. That VSAT device will send my information to the regional office. That regional office will respond my request and get back and reply to my request back. So I can say that VSAT technology we are using in ATM machines. I will give you the another example of VSAT. we are using VSET machine, VSET device also in at our homes, like we are using Tata Sky, we are using Airtel or any other modes that also use a VSET device. I mean, here we are seeing this diagram. This diagram is having a transponder. This transponder, I can say this is an example of VSET. That this will send my data to a satellite and it will get back. Now, router and switch. They both are the networking devices. First I will teach you the switch, then I will teach you the router. What is a switch and what is a router? When I'm using a switch, that means let's take the switch. This is the switch diagram. Let's take this example. There are 4 computers here, and they 4 computers are connected with a switch. Now this switch is using only one. We are using switch in only in one network. I mean, here the computer are connected with the switch, and the switch will respond to this 4 computers. Now, but in case of router, I can say router is used to connect 2 different networks. That is the main difference in router and switch. In router, we have 2 different networks, but in switch we have only one single network, in which in one single network I will say in the switch 4 computers are connected, and these 4 computers are communicating with the switch. Now taking the example of router here, as I told you that router has more than one network. So as we can say we can see the definition, a router is a device that forward data packets between computer network, creating an overlay network. So now, as I told you, switch is used only for one single network and router is used for 2 different networks. Now coming to gateway, I will give you the example of gateway, that when I'm entering my home from the road and I'm opening the gate of my home. When I'm entering my home, I'm opening the gate. Before that, I'm in the road. So there are 2 different, I can give see that there are 2 examples. There are 2 different ways. First I'm in the road, then I will go to the home. So first is first network and another one is second network. Here also we have 2 different networks, and a gateway is used to connect 2 different networks, 2 dissimilar networks. Now coming to the repeater. Network repeaters regrets incoming electrical wireless optical signals. What is, first of all, before going to this now let us discuss about the router. Before that we have discussed about the switch. Now we are discussing about the router. What is a router? Now we have discussed the switch. Switch is what? We are using a switch in a particular network, in particular building, and we are connecting different computers with a switch. But in router, there is very difference in router and a switch. In router we are connecting 2 different networks, not a single network. I mean, for example, I can say we have 2 buildings. One is building A and one is building B, and we are connecting these both buildings with the help of a router. Now in that building we will use a switch, and that both switch will be connected with a router. Now we will also see the definition of a router also here. A router is a device that forward data packets between computer networks, creating an overall internetwork. A router is connected to 2 or more data lines from different networks. As we are seeing here, 2 types of network, 2 types of routers. Before that, we will see the definition that a router is a device that forward data packets between computer network, creating an overall inter-network. Now, here we are seeing this a router. Here we are seeing different ports of a router. Now, these different ports are used to connect to different networks. One thing I will say in switch and router also, a router is a secure device, but a switch not. And also router, I can block an IP, I can block a network, or I can block a particular system's IP or a network IP with the help of a router. If I don't want to, if I'm in a lab, or I'm in a office, and I don't want to use a particular network's IP, then I will that particular IP from the use of a router. And one thing more, that switch works on data link layer, but routers works on network layer. As I told you that it will see what? It will see the IP address of a particular system. Now, after router, we have a gateway. What is a gateway? We have two different networks. One is network A, one is network B. And we are connecting that both networks with the help of a gateway. For example, let us say we are going to our home. And first we are in the road, and after that we will enter at our home with opening a gate of our home. So we can say there are two different networks. First is I am on the road, and another one is my home. Now I am opening the gate. Then when I am opening the gate, I enter to the home. So first is my A network, that is my road network, and second one is my home network, that is network B. So I am connecting that both networks with the help of a gate. Now here also I am connecting this both networks with the help of a gateway. We will also see the definition of this gateway. A gateway is a network point that acts as an interface to connect two different types of network, as I told you. Now, coming to the next slide, a hub. Particularly, we will use switch, and we can also use hub in a particular small network. But here, a little bit difference in hub and a switch. That is, in a hub, we can use hub only for small networks, like we have 4 to 5 computers. But in switch, we can use more than 5, 6, 7 or 10 or 15 or 20 computers. But in hub, we can only use hub for a small network. Like here we can see the definition of a hub: a commonly connected point from devices in a network. Hub are commonly used to connect segments of a LAN, as I told you. And here one thing more, that this hub is work on physical layer. As I can say, hub work on physical layer, switch works on data link layer, and router works on network layer. This is a very important question for your IBPS SO exam, because this question again and again, this question has came in 2012, 2013, and I think this question will come in 2015 or 15 and 16 also. Because as we are talking about the networking, so we should know about this particular basic terms: hub, switch and router. Now coming to the next slide, I already discussed about the switch. Now the repeater. I will give you a small example of a repeater. When I live in a cant area, or I live in a restricted area where the signals are not coming in my home, or in the cant area. So what I will do, I will increase the signals capacity. Capacity means I will increase the signal strength. How can I increase the signal of strength? I will increase the signal of strength with the help of a repeater. What companies are doing? They are using a Wi-Fi network, and after we can say that a Wi-Fi network is having some limit, and after that limit the Wi-Fi network will not work. But I will increase the capacity of a Wi-Fi network with the help of a repeater. Here, same example, I told you that I will use this repeater in canned area, as I told you. So as we can see the definition also, network repeaters regenerate incoming electrical, wireless or optical signals, as I told you. With physical media like Ethernet or Wi-Fi, data transmissions can only span a limited distance between the quality of the signal degrades. As I already told you, this will increase the quality of a signal. I can use a repeater to increase the strength of a signal. Now coming to the next slide, there are different types of topologies. First of all, we will discuss what is a topology. Topology means, as we are going to any home, or we are going to any office, or we are going to any lab, we are seeing that the computers are arranged in a particular order. So I can say arranging of system in a particular order, we can say a topology. Topology, arranging of systems. I mean, I can use cables or I can use a Wi-Fi network to connect these systems. First, we have a star topology. But I will start from a bus topology because this is a very basic topology. What is a bus topology? Now, let me discuss about the bus topology. I will take an example of a bus topology. Suppose here this is a main central cable and we are connecting the system here with the cable. Suppose system 1, system 2, system 3. Here system 1, system 2 and system 3. Now suppose we want to transfer data from system 1 to system 6. Let us say this is system 6. This is 1, 2, 3, 4, 5 and 6. Now we want to transfer the data from system 1 to system 6. Suppose in system 1 the person wanted data from system 6 or system 6 wants the data from system 1. When system 1 sends the data to system 6, the data will be transferred in each and every computer. I mean, it will be transferred in computer 2, computer 3, computer 4, computer 5 as well as computer 6. Now, when because here all the computers are connected with a single cable. So we can say this topology is very slowest topology as compared to other topologies, as we will discuss later the other topologies. Here, as I told you, because each and every computer when send the data to other computer, the data will be sent each and every node, each and every computer. Now, but here in bus topology, the main factor is that a server is connected here, and if server sends the data to a particular node, then also the data will be sent each and every node. And if a particular computer sends the data to a particular node, then a particular node will send the data to a particular node, then also the data will be sent each and every node. Now coming to the second topology. Before coming to the second topology, let us discuss about the basic terms of bus topology, a basic definition of bus topology. Bus topology is a type of network setup where each computer network device is connected in a single cable or backbone. As I told you in the example also, that each and every computer is connected with a single cable. Now coming to the second topology. स्लाइड पूरी एक बार कट करना पड़ेगा सर, स्लाइड पूरी उल्टी सीधी हो गई. Now let us discuss about the second topology. We have the star topology. Now before coming to the star topology, let us take the example of star topology. Suppose there is a central server here and the systems is connected with the servers like this. Now, as we have seen in the bus topology, when we are sending a data from one system to another system, the data will be sent to each and every computer. I mean, I can say, suppose I told you that from system 1 to system 6 I want to send the data, then the data will be sent to system 2, system 3, system 4, system 5 and system 6 as well. Now, but in this ring topology, there is a central server and the server is connected to each and every computer. And here, suppose we want to send data from system 1 to system 3, then the message, the data will be sent straight to system 1 to system 3. So we can say that this is the fast topology as compared to bus topology, because we are sending the data very fastly from first node to another node. As I told you that from system 1 to system 3, the data will be sent directly. Now, let's come to the advantages of star topology and also where we will use star topology. I will give you the example of star topology. We will use star topology in banks. As we know, whenever we will go to a bank, if there is some problem in the server, then the bank person will tell us that there is a problem in the server, but that problem is in the whole branch, not even in a single server, not even in a single computer, or not even in a single network, but that problem is in the whole computers, whole server, whole network. Now, here the disadvantage is that in this topology, whole the process is turned with server. I mean, if the server process is down, the whole topology will be down. So the advantage is that this is the fast topology as compared to bus topology, and the disadvantage is that here if server is down, then the whole topology will be down. So let us come to topology. So here also we are seeing that this is a central server and whole the system is connected with a particular server. Now here we are seeing that the disadvantage in this topology is that the server is the main key factor here. If the server is down, then the whole topology will be down. Now we will change, we will go to the next topology, which is the more better than this star topology. Next topology is, we have a ring topology, or before ring topology we will take a tree topology. Let's go to the tree topology. We will take an example of tree topology here. As we have seen in before in star topology, that the system, that the message is sent to each and message is sent with the help of a central server. But here in tree topology, what we will do, we will use a central server here, and the central server will be connected to the different servers like this, and this server is connected with the computer like this. Now, as we have seen in star topology, if the server has become down, the whole topology will become down. But here we have a backbone of the main server. Suppose the server is become down, then this, this in city A, suppose this is city A, city B and city C. Suppose city A server become down. Now the person which use this network will go to the main network, the base network. The data will be transferred from this base server to the main server. Or I can say that here, if suppose this server becomes down, then the whole process, the whole data will be sent to the main server. Or I will give you the example like Google. I can say Google is using the same topology. Means Google is having different headquarters. Like the main headquarters is in USA, and in India we have in Bangalore. Now when we are typing www.google.com, and we will enter it, it will go to the Bangalore's or Hyderabad's server, not to the US server, because we are using here that a local server. And one more thing, that I can say that this topology, I mean this tree topology, is also a combination of what? A combination of, I can say this, what is this topology? This topology is, which topology is this? This is star topology. This is also star topology and this is also star topology. So I can say that tree topology is a combination of star topology. Is it clear? Now coming to the next topology, let us take next topology as a mesh topology. Now coming to the mesh topology, in mesh topology each and every computer is connected to each and every computer like this. I mean there is no, I don't use any server here, because each and every computer is connected to each and every computer. When I will send data from system 1 to system 2, the data will be sent automatically to system 1 to system 2. There is no need of any server or there is no need of anything, because this topology, each and every computer is connected to each and every computer. So I can say this is a fast topology than what we have studied earlier. This is the fast topology I have seen. But there is a disadvantage in this topology. The disadvantage is that in this topology, as we are seeing, each and every computer is connected to each and every computer. So here, if we are using only 4 computers and we are using 6 to 7 cables, but if we have 100 to 200 computers, then we have to connect 100 to 200 computers with each and every computer. So for that, there is lot of money is required. I mean, I have to purchase these cables for that. So I can say this is the most moneyful topology. I mean very costly topology, I can say. This is the most costly topology. And also I will tell you that a question came in 2014 to 15 SO exam, that which of the following topology which you have studied now, which of the following topology we have used in internet. I mean which of the following topology we have used in internet. So I can say we use mesh topology in internet, because in internet what we will do, we will send the data when we will write google.com or we will write yahoo.com and we will enter it, then our request will go to a main server and server will respond to our request. So we have connected from one computer to a server and a second computer also from the server. Now coming to the next topology, let us take next topology will be our ring topology. Now coming to the ring topology here, in ring topology each and every computer is connected like this, like a ring. I mean here if we want to send the data from one system to another system, we can easily send from one system to another system with the help of a cable. Because why we say this is a ring topology, because the computer is connected in the shape of a ring. But as we have seen early topologies also, I mean if I will take a example that this type of topology, I mean not similar but something similar topology is we have seen in bus topology. Like in bus topology also we have a single cable, and here also we have a single cable. But in bus topologies the cable is not connected to a first node, but here the cable is connected to a first node. Now first thing is that the cable is connected to a first node, so it is a circular cable, so we can say this is a ring topology. And second thing is that here when I want to send data from system 1 to system 4, here in bus topology, when we are sending the data from system 1 to system 4, the data will be sent to each and particular node. But here in this topology, when I am sending the data from system 1 to system 4, first system 1 will send a token to system 4. When system 4 accept the token, we can say a token. When system 4 accept the token, then system 1 will send the data to system 4 and system 4 will accept that data. And system 2 and 3 will ignore that data. So this is also a very good topology, and this type of topology, we can say this type of topologies are commonly used in some organizations or in some institutions. Now coming to the next topology. Our next topology is hybrid topology. We have discussed bus topology, we have discussed mesh topology, we have discussed tree topology, we have discussed ring topology, we have discussed star topology. Now the last topology is our hybrid topology. What is hybrid topology? Hybrid topology is a combination of two or more than two topologies. And then I can say more combination of two or more than two topologies is called a hybrid topology. Now let me take a brief of these topologies. Let me take a brief of these topologies once again. I will go through very fastly so that you can remember all the topologies. And this is the very important topic of this SO exam, because in SO exams they will ask you the basic terms of network, and in basic terms topology is very important topic for SO exam. So let me take a brief of these topologies. First we have discussed about bus topology. This is our bus topology. Here we have a central cable and all the systems are connected with this central cable. Then we have discussed about star topologies. Here we have a central switch or a central server which is connected to each and every node. Then after that we have discussed about tree topology. This is tree topology which I discussed, and this is mesh topology. Each and every computer is connected to each and every node as I told you. Now this is hybrid topology. As I told you that it is a combination of two and more topologies. Here we are seeing one topology, second, third and fourth, and it is here we have used a particular device, a particular networking device, and we have combined all these topologies. So this is our hybrid topology. Forward, now we will discuss about ISO OSI model. This is a very important model for your exam, because 1 to 2 questions will come from this part. What is ISO OSI model? What are the layers in ISO and OSI model? What is the first layer, which is the 7th layer, which is the 5th layer of ISO OSI model? Before coming to ISO OSI model, let us take what is a ISO OSI model. Why we have created this model. We want to send the data from a particular network to network. For example, from particular system to a particular system. For that, we will use this OSI reference model. From one system, then to a particular networking device, then particular networking device to a particular different network, we will use this ISO OSI model. Now, before coming to each and every layer, let us see how many types of layers are there and what are the process of that layer. There are 7 layers in ISO OSI reference model. First layer is physical layer, second is data link layer, third is network layer, fourth is transport layer, fifth is session layer, sixth is presentation layer, and seventh is application layer. This all layers will do different tasks at different time. Let us take an example. Suppose this is my network and the computers are connected like that, and this is connected to a server, and server is connected to firewall, and firewall is connected to our networking device. Suppose it can be a hub, it can be a switch, or it can be a router. Now this router is connected to our ISP, Internet Service Provider, for example. Now first layer is our physical layer. What physical layer will do? Physical layer will check the physical media. Here we are using different types of media, as we have discussed earlier that there are different types of medias here, and here also we are using a media like this media. This is what? This is a physical media, physical layer. Physical media means we are using a cable. Which cable? It can be Ethernet cable, or it can be suppose it can be a coaxial cable, or it can be any type of cable. Now this cable is connected to a server. First physical layer will, what physical layer will do? Physical layer will check the physical media. What he will do? He will check the physical media of particular system, whether they are connected or not. Now coming to the data link layer. What data link layer will do? Data link layer will check the error detection and error correction. The data which is sent from these systems, that data is particularly which is sent, that is correct. I mean they will check the frame release, they will check whether there is any error or not in that particular network. After data link layer, the data will be sent to the physical layer, network layer. Now when the data will come to the network layer, here we will use, in network layer we will use a router. And once I will repeat one thing here, that is physical layer we use hub, data link layer we use switch, and network layer we use router. So as now coming to the network layer, now network layer, what network layer will do? Here router will come, and router will check the IP of a particular system, whether this particular server's IP is blocked from the router, or whether the particular system's IP is blocked from the router or not. I mean it will check some IP address. What IP address? IPv version 4 or IPv version 6. It will check. Now at present we are using IPv version 4, so it will check IP version 4 address, that particular address is correct or not, and it will send the data to the transport layer. Now our data is ready to be transported from our router. Now transport layer will work. In transport layer there are two protocols. One is UDP and another one is TCP. First is TCP, second one is UDP. What is TCP? Transmission Control Protocol. And what is UDP? User Datagram Protocol. In TCP, the data is sent, I mean it will connect a distance from router to ISP. I mean the data is sent with connection oriented method. Connection oriented means data is sent from router, I mean it will connect a physical path, and the data will be sent from router to a particular ISP. Let us take an example. Suppose I want to travel from Lucknow to Chandigarh, and I don't know how can I travel. So first I will go to the railway station. First I will go to a particular area. Then I will ask a particular person that I want to go from Lucknow to Chandigarh. So how can I go? He will tell me that there is two ways. You can go from the busway, or you can go from a railway. Now it is up to me that what I will decide. If I will decide I will go from railway, then that is my final way. I mean I have already decided that I will go from the railway. So I will put in the train, and I will go through the train. But if suddenly after some time the train's engines become fail, I mean so there is some problem in the engine, I will be in the train because I have chosen what? I have chosen the TCP. TCP means connection oriented. The data will be sent from a particular direction, and it is connection oriented. But suppose I am using UDP. UDP means user datagram protocol. Suppose I will use UDP. In UDP, what will be done? This is not connection oriented, this is connection less. Suppose the same situation will occur here, the train's engine become fail. Now what I will do? I will get out from the train and I will catch the bus, because this is connection less. This is connection less and this is connection oriented. TCP is connection oriented and UDP is connection less. Now, after coming from the router, the data will reach with the server, or we can say the ISP, or suppose the ISP will send the data to the server. Now data has came to the server. Now after transport layer, the session layer has been started. Now what the session layer will do? First, session layer will create a session. It will create a session that the data which is came, that is, when the data will enter into the server, then it will the session will be created, that when the data will be there in the session layer, then a particular short session will be created. If the server will give the answer to a particular data, then the data will be executed, or it will send a message report. For example, I can give you the example of IRCTC. Whenever we are doing the reservation, and when I will go to the final stage, when I will do the transaction, at the time of transaction, what will be occur? At the time of transaction, when session layer enters, in IRCTC, suppose in the final transaction, when session layers enters, the data is entered in the session layer. If suppose the server is not responding, the request has been sent to the server, but server is not giving the response, then it will transport layer, this session layer will be, it will keep the data for 6 minutes. After 6 minutes, the data will be terminated, and I will get a message that this particular page has been session out. The session has been expired. So now what this session layer will do? Session layer will do some creating the session or terminating the session. After session layer, again when session layer will respond the data, again the data will go to the presentation layer. Now presentation layer, what the presentation layer will do? It will decode or encode the data, and after the final process, application layer will occur. So now let's come to the slides. As we have discussed, I think we all have now a brief discuss about this 7 layers, and we will get about. Now coming to the brief discussion of ISO OSI reference model. In previous we have discussed about a diagrammatical OSI reference model. Now we will take one by one the layers, and we will discuss which type of protocol we use in different types of layers. Now first protocol we have is physical layer. First we will see the definition of physical layer. This layer conveys the bit stream electrical pulse, light or radio signals through the network at the electrical and mechanical level. As I told earlier in the diagram also, the main feature of this layer, you can see the examples also. We use USB cables, NIC cards, cables, DSLs, ISDNs. All these are the examples of this physical layer. Here in this definition also, it is telling the same thing which I told you in the diagram. After coming from the physical layer, we have data link layer. In data link layer, I told you it will check, if we will see the definition, it furnishes transmission protocol knowledge and management and handles error in the physical layer. As I told you, it will do the error management, and the protocols here we use in data link layer are PPP, triple P, point-to-point protocol, ATM, ARP, bridge, gateway, switch. As I told you, switch works on data link layer. In the diagram also I have told you that when we have used the switch, that switch works on data link layer. Now in network layer, first we will see the definition of network layer. This layer provides switching and routing technology, creating logical paths known as virtual circuits for transmitting data from node to node. Routing and forwarding are functions of this layer, as well as the addressing, internetworking, error handling, congestion control, and packet sequencing. As I told you that in this layer, network layer, we have IPv version 4 and IPv version 6. As I told you, here in this network layer, the router is worked. So In physical layer, we have hub. In data link layer, we have switch, and in network layer, we have router. Now coming to the next layer, we have transport layer. That is, this layer provides transparent transfer of data between AND systems or hosts and is responsible for end-to-end recovery of flow control. As I told you that when we will send the data, in the diagram also I have told you that when we will send the data from the router to a particular ISP or particular server, then we use this type of TCP and UDP layer. So we can say that TCP and UDP are the example of this transport layer. Now come to the next layer, that is session layer. As I told you, it will terminate and manage the session. As I give you the example of IRCTC in past in the diagram, that when the message has been sent to the server from the IRCTC, from the gateway server of the particular bank, and when the data is sent in the particular server of a bank, and if the server of the bank is very busy, then it will consume the data. I mean, at that time session layer will be started, and session layer will consume the data, and it will start the time. Suppose it will start the 6-minute timer. Now after 6 minutes the session will be expired. And the examples of session layer is SAP and SOX. Now coming to the sixth layer, as I told you, the sixth layer will do, this layer provide independency for difference in data representation, in example encryption. As I told you that this will do the encryption and decryption of the data. And the protocols we use in all extension files, the extension files whichever we have used in the computer, they all are the example of this presentation layer. Now the next layer is application layer. In the application layer, first we will see the definition. This layer supports applications and end user processes. This layer provide application service for the file transfer, email and other networking software. Now at the end, when the data has come, I mean, as we will see the example of the protocols here in this application layer: HTTP, FTP, Telnet, DHCP, DNS, SMTP. This all protocols works on the final submission of a server. When the data comes in the server, then this protocols will work in under application layer. Now this is the whole brief example of OSI reference model. Now we will come to the TCP IP model. Now here it is TCP IP model. What is TCP IP model? See, in OSI reference model we have 7 layers, but in TCP IP model we have 4 layers. In 4 layers, first is application layer. In application layer we use application layer, presentation layer and session layer. Second one is transport layer. In transport layer we use transport layer. The third one is internet layer. Fourth one is link layer. In this we use data link and physical layer. There is no session layer as presentation layer applicable in TCP IP model. And this type of model we use in internet. So we will see some protocols in this TCP IP model, as this TCP IP model is very important for IBPS SO exam. So let us discuss about some protocols here in this TCP IP model. First, in application layer, we have some protocols like DNS, DHCP, Dynamic Host Control Protocol, File Transfer Protocol, HTTPS, Hypertext Transfer Protocol, Secured, IMAP, LDAP, NTP, POP3, RTP, RTSP, SSH, SIP, SMTP, Simple Mail Transfer Protocol, SNMP, Telnet, and TFTP. These are some important protocols we use in this application layer. If you want to note down, you can note down this protocol. These are very important protocols. Some questions have came from these protocols in the example. In some questions, they have asked the full form of these protocols. So you may write down this protocols in your notebook also. Now in the presentation layer, we have JPEG, MIDI. These are all are the extension files. JPEG we use for images, MIDI for music, MPEG for videos, pictures, TIFFs. And in session layer we use NetBIOS, NFS, PAP, SCRP, SQL, ZIP. And in transport layer we have TCP UDP, as we have discussed earlier also, TCP UDP. And in internet layer we have network ICMP, IGMP, IPSC, IP version 4, IP version 6. And in link layer we have data link layer and physical layer. In data link layer we use ARP, ATM, CDP, FDDI, frame relay, HDLC, MPLS, triple P, STP, token ring. And in last, in physical layer we use Bluetooth, Ethernet, DSL, ISDN 802.11 and Wi-Fi. Here in OSI reference model, in TCP IP model, I can say in OSI reference model it might become 2 to 3 questions, and from TCP IP model they will ask the full form of this protocols. Now coming to the next section of this session, that is some examples of some protocols. We have seen the protocols in earlier in TCP IP model and in OSI reference model. Now we will see the brief description of these protocols. Please write down the full form of these protocols in your notebooks so that it will be very easier for you when you will prepare for the exam. First is DHCP, Dynamic Host Configuration Protocol. This type of protocol we use in the main server to provide the IP addresses to a particular systems. Here also in the definition we can say it is a network protocol that enables a server to automatically assign an IP address to a computer from a defined range of numbers. That I already told you that we will use this protocol to provide the IP address to a particular systems. Second one is TCP, Transmission Control Protocol. Here TCP means is a standard that defines how to establish and maintain a network conversation via which application programs can exchange data. This is, I can say, this is connection oriented protocol. In OSI reference model also, when we have discussed about this TCP and UDP protocols, in that also I have told you that this TCP is connection oriented protocol. Please focus on this word, connection oriented protocol. Now coming to the next slide, UDP, User Datagram Protocol. I mean that is connection. That is connection oriented and this is connection less. So please write down this definition. The definition says UDP is a connectionless internet protocol. Multiple messages are sent as a packets in chunks using UDP. I can say in brief that UDP is connectionless. Now PPP, point-to-point protocol. In point-to-point protocol, it is a data link protocol commonly used in establishing a direct connection between two network nodes. We can connect two different nodes with using this triple P protocols, and it is used to communicate between two computers using serial interface. And typically a personal computer connects by phone line to a server, which as you are using, I mean I can say I will give you the example. Just you are using the DSL line or ADSL line at your home to connect the internet. So in that I can say that is the best example for this PPP protocol, point-to-point protocol. Now coming to the next slide, we have CSMA CD, Carrier Sense Multiple Access with Collision Detection. What is it? This is CSMA CD. CSMA CD, this is used for the collision erection and collision detection protocols. I mean whenever the collision is occurred in the network, this protocols works there. Let us see the definition of this protocol. It is a media access control method used most notably in local area networking using early Ethernet technology, and it is used a carrier sense scheme in which a collision is entirely avoided. Whenever we have a collision means when the data collided with each other, then that time we will use this CSMA and CSMA CD protocols. Now coming to the next slide, we have internet protocol. Before coming to the internet protocol, I will take some examples to tell you what is a IP address. Now suppose I will take an example of an IP address. First, what is an IP address? What is an IP? IP means internet protocol. What is internet protocol? Internet protocol means a particular address which is known for the particular computer. I mean as I want to go to some my friend's home, what I will do, I have the address of a particular my friend's home. I mean, I have the address. Whenever I will go to my friend's home, I have the address. But here in the computer also, whenever I will send data from one system to another system, I have the particular address. That particular address will known as the IP address, Internet Protocol address. Now, let us take an example of an IP. Suppose I will take an example 1.2.3.4. This is a particular IP address. Now, here in this IP address, this first node, one thing more I want to tell you in this IP address, that this is the 4-octet IP address. This consists of 4 octets, octet 1, 2, 3 and 4. And this is 32-bit IP address. This is 32-bit. Okay, this is 32-bit. And the first octet of the IP address is represented by a class. First address of a particular IP is represented by a class. Then first I will tell you what is a class. I mean, suppose what I will do, as I told you that a particular server or a particular system is known from its IP address. Now what I will do, I will divide a particular system with a particular class. I mean, suppose I am making a particular, suppose I am making a government website, or I am making a particular MNC's website. What I will do, I will choose a particular class for a particular website. Here I have taken the example 1.2.3.4. Now, before coming to more brief of the IP address, let us see the let us see this diagram, that here let us see this diagram before coming to the IP address, that here what I told you, that we are using some different classes. So we have 5 types of classes here. First is class A, which is ranges from 1 to 126. Then its default subnet mask. Default subnet mask means sending of data from one network to another network. Suppose we want to send the data from the cable to the to our system, then this subnet mask will be used in that case. And here the maximum host will be 16 million. And in class B, the starting range is from 128 to 191. Subnet mask is 255.255.0.0. In class C, 192.223, and the subnet mask will be 255.255.255. And in class D, the starting range will be 224 to 239, and there is no subnet mask. And in class E, 240 to 255, there is no subnet mask, because class D we use for we normally use class A to class C. Class D is used for unicasting, multicasting, and class E is used for future use. So now here we have taken the example, this example 1.2.3.4. Now here in this example, the first node is representing the class, which I told you. So I can say that here in this example it is 1, and in class A the range is from 1 to 126. So I can say that this particular IP ranges from class A. Now this is the basic thing. Now I will come to some advanced thing. I mean, how can I provide the IP to a particular system? I mean, if there is a particular IP for a particular system and I want to provide the IP to second system, how can I provide the IP? Now take an example. Suppose let us take an example of IP 162.128.0.1. Now 162.128.0.1 this is a particular IP. Now here in this example we have 128 to 191, that is from class B, and here I took 162. So I can say that the class of this IP is class B because it contains 162, and the range of class B is we can say class B is 128 to 191. Now suppose this IP I have given to a particular system, and now I want to give IP to another system. So what I will do, suppose I have taken another system. Now what I will do, I will increase this octet, because in this example the first octet represent what? First octet represent the class. I cannot change the class, and I cannot change the class, but I will not change this byte and this octet and this octet also. I will change the last octet of this IP. Now the next IP will be 162 dot 12 dot 10 dot, sorry, it will be 162.12.10.2. Now what I have done, I have increased the octet of a last IP. I mean this IP last octet I have increased from 1 to 2. Then I will increase to 2 to 3, 4, 5, 6 up to the maximum range will be 255. Let us take another example. It's a very small example. Suppose we have 3.0.0.1. Now we want to provide the IP. This IP is for particular system A, and we want to provide the IP to system B. What we will do here, first octet represent the class, so we can say this is from class A. Now what we will do, we have to provide the IP to class that particular system B. What we will do in next PC, what we will do, we will increase the octet of the last bit. I mean in next PC, what I will take, I will take 3.0.0.2, and it will increase up to 3, 4, 5, 6, 7, 8, 9, 10 up to 255. After that, after 255, what will be done? After 255, this the next bit, because here we cannot change this because it represents the class. What we will do, we will shift this bit to the left one, I mean here. Now if it's the maximum bit of the maximum range of the final bit is 255. Now if I want to add another system, what I will do, I will just shift the bit to here, I mean 3.0.1.255. I can say, but here it will not come 255, it will become 1, and it will increase, I mean it will become 1, 2, 3, 4 up to 255. These changes will be occur in class A, but in class B, as I told you that this is the example of class A. Now I am taking the class example of class B. In class B, I can change the same thing, but here one thing more important for you, that here I cannot change, I mean here in class B, I cannot change the particular last bit. I will only change the bit of last octet and second last octet, but I will not change the bit of first and second octet, because first octet represent the class, second octet also a network ID, and third and fourth are the host IDs. For example, I will take, suppose it's 129 129.3.0.4, suppose. Now what I will do, these 2 bits are from network and 2 bits are from host. I will change these 2 bits, but I will not change this network ID bits in class B. But in class C, what I will do, first node in class in class A, the first node represent network node, second is host, third is host, and fourth is host. I mean I can change these 3 bits but I cannot change this network bit. In class C, there are 3 network bits and 1 is post bit. I can change this post bit, but I cannot change this network bit. But in class D and E, D class is for unicasting and multicasting, class E is for future use. So these are the examples of this internet protocol. You can note down this, from class A to class E if you want to note down. And this is the very important topic for your networking purpose. 1 to 2 questions maybe come in from IP protocol. Now coming to the next slide, a very important thing is here that as you see that in the previous slide, the first range is from 1 to 126 and the second is from 128 to 191. But you will see that there is no 127. Where is 127? Here you can note down that 127.0 dot 127.0 0.0 to 127.255.255.255 is what? Is reserved for loopback adapter. So you can write down this from 127.0.0.0 to 127.255.255.255 is reserved for loopback adapter. This is very important questions. It can become in your exam. Now coming to the next slide, as there are 2 types of IPs. One is IP version 4 and another one is IP version 6. We have discussed IP version 4. Now we are coming to IP version 6. There is no class in IP version 6 right now, but the important thing is that in IP version 6 we have 128 bit of address, and here we have 64 bit of network ID and 64 bit of host ID. If you want to note down, you can note down this, that first is 64 ID network ID. You can note down the total bits, that is 128, and here one is 64 bit network ID and 64 bit is host ID. Coming to the next slide, MAC address. What is a MAC address? As I told you that our system knows from the IP address, but our system is also having the MAC address, media access control, which consists of some numerical values. Let us see the definition of MAC address. The media access control address is a binary number used to uniquely identify computer network adapters. These numbers, sometimes called hardware address or physical address, are amended into network hardware during the manufacturing process or stored in firmware and designed to not to be modified. As I told you, the IP address can be changed, but MAC address cannot be changed because this is the machine address of a particular system. Now coming to the next slide, here also we are seeing some MAC examples here. That is, traditionally MAC address are 12 digits, 6 bytes and 48 bits, and it is in hexadecimal numbers. For example, we are seeing MMM, SSN, and is the leftmost 6 bit is 24 bits prefix. Now coming to the next slide, so we have completed network right now, and I hope that this session has helped you a lot, and please visit Bankers Guru always. Please give the online PSS. We all are available on online PSS for you at every time. Thank you.